Welcome back, guys. Most of the grade 10s have been requesting that I must also do a question paper, which is from Limpopo, also from for grade 10s this time, because a lot of you guys have been requesting for this paper on the comment section. On this video, I'm going to cover it. Hopefully, by now you're a little bit anxious. You want to prepare for the March exam. So this question paper is going to just help you practice there and then. So I have this question paper. You can go to the description box right now and go and check it out. So it's a grade 10 paper. First, I will advise you to just download it, try to do it on yourself, and just come back to use this video as a reference for explanation for certain questions. So this is for March exam that was written last year, which is 2025. It was out of 75, which was required to be written for 90 minutes. So the instructions are not important. We can just skip them. You can read them out if you want to. But for me, I would just skip them for now and focus on the question. So our question one is this one. It carries almost 20 marks. So this is a combination of number system and also algebraic expression, which these two types of topics. I have made the videos here on YouTube. If you have not yet watched it, guys, please go and watch it, because a lot of methods I'm going to use in this video, in this question paper, I have already taught them in my YouTube videos. Go and watch them. A lot of stuff, and I will keep on repeating this throughout this question paper to just remind you that I have already have videos of this type of stuff. So without wasting more of your data, guys, let's just quickly start with 1.1. So 1.1, start with this one. So answer the following. 1.1, given a set which is all these numbers that are here in no particular order. In other words, that's trying to say that these are not in order. Write down two non-real numbers, not real numbers. So you might be wondering, what are the non-real numbers? Let me just give you a quick definition. That is, what is a non-real? A non-real is that kind of number that when you punch it in your calculator, you're going to get undefined. That's all. That's a non-real number. A non-real number is the number that when you punch it in a calculator, you're going to get undefined. So if you take a calculator then and try to punch this one in your calculator, it's not going to give you undefined, and also this one not undefined. But this one, try it in a calculator, they're going to get undefined, and also this one is going to give you undefined. The square root of this is going to give you 0. This one is not undefined. So the one is going to give you undefined. That is a non-real number. So what are the two non-real numbers here? It's the square root of -2 and the square root of -4. This it gives us undefined. So therefore B, what are irrational numbers? Irrational numbers, guys, are those kinds of numbers that cannot be written that cannot be expressed as a fraction of two whole numbers. So in an irrational number, here is going to be this pi. So you are going to have pi, because this one we can write it as a fraction of two whole numbers, and also this one we can write it as a fraction, and also 0 can write it as a fraction. So that one is going to be a pi for this one. So moving on to my favorite question, guys. I have videos about this type of questions. If you want to master them and don't want to get it wrong, I have videos of them in a number system playlist. This one, this blue one, go and check it out there, guys. It's going to help you understand a lot about this. Determine, without using a calculator, two integers between which -√7 lies. In other words, they just want two integers. Okay, let's just first define what is an integer. An integer is all the numbers on the number line except the fractions. The number line, we have this number line, we have let me just quickly 0, 1, 2, -1, -2, all this, but it does not include 1/2, 1/6, something like that. Does not include fractions, and also decimals. If that kind of number it includes decimals, it's not an integer. So what they're basically saying in this question, they want you to tell them what are those kinds of two numbers that can be able to be found between this -√7. So this type of questions, guys, are very, very easy. Let me just try to bring out my calculator here. So this is my calculator here. So what you need to do here, you need to first understand this number that is here, the fraction or like the decimals of it. You can just like say negative root 7, So negative root 7, this negative root 7 is the same as negative 2,6. I just like put in 0,65, So they want you to give them two numbers that is between this negative 265. That lies between. It means, for example, this type of question is just like the same as when they're asking like, for example, let's say we have 14, and then they ask you, give us two numbers that found between 14. Two numbers that found between 14 is going to be 15 and also 13. These two numbers are the one that is found between 14 here. So this is the same question that they're asking you. They just want to know which two integers, real numbers actually, that can be able to be found inside this. So once you have this, it's going to be very, very easy to figure it out, that kind of number. So we're going to use a number line like this. So let's say negative 2,65 is going to be here. What will be two numbers that will be between these two numbers? What will be two integers, not decimals, but integers? Remember, on our number line, we have the negative and the positive. Now we're talking about the negative side. So hopefully, here there will be number like negative 3. And here there will be number like negative 2. Here there will be number like negative 1 and 0, and then here there will be a number like negative 4, So the numbers or the integers, just pay that I didn't use any decimals, I just used the integers. The integers that are found between this number, negative 2, is what? It's negative 2 and also negative 3. They are found between this integer, which is negative root 7, So these are the integers that you got there. So what can we do to answer this kind of question? So just going to just take them. So this is going to be negative 3. So when you want to represent in between, you write this two things like this, and then you put that root 7 here, and then you put that negative 2. So this one is going to give, you're going to get those kinds of answers of yours, 2 marks for this type of question. So if you have not yet understood it, please check out those kinds of videos. I've demonstrated this method a lot of times. Let's just move on to the next. So 1.2 is determine the product for 4 marks. So this one is a little bit easy. We just need to distribute. So I'm going to take this one, multiplies here, multiplies there, and also multiplies there. So x multiplied by x is going to give us x squared. X multiplied by negative 3x is going to give us negative 3x squared. And then this x multiplied by 4 is going to give us plus 4x. And then we're going to take these 2 multiplies here, we multiplies there, and also multiplies this one. So 2 multiplied by 2x is going to give us plus 2x, and 2 multiplied by negative 3 is going to give us negative 6x, and 2 multiplied by 4 obviously is going to give us positive 8. So what we need to do next is just to group the like terms, something that has I forget the square here. So this one's going to give us 2 square, and just forget the square. So now we can be able to group our like terms. So the like terms are these and also these. Why are they like terms? Because they have the same term there here. They have squared and also squared, so they are called the like terms. So also the other one that I like terms is this one and also this one. So we need to add them up. So in the calculator, we're just going to put negative 3 and 2 and then get the answer. Here we're going to, this one is cube, guys. I'm sorry. So this one is cube. I'm really, really sorry for that one. I'm just a little bit in a hurry. I don't know why I'm doing this. So negative 3 plus 2 is going to give us negative 1, which are going to be left with negative x squared. And 4 minus 6 is going to give us negative 2x. And we're going to be left with positive 8. So we're going to be left with positive 8. So this one, I'm going to leave it here. This will be our final answer. So 1.3 is that factorize fully, So in order for us to factorize this for these 3 marks, we need to factorize by grouping. How can we do that? So we're going to just group 2 terms together. So we're going to first group this one and also group that one. This is the only way we can be able to factorize this. So we're going to have 4b squared minus 8b and then we're going to group this one and also group this with its own minus, with its own sign. So we're going to have negative AB plus 2A, yes. So this is the first step. We just group. So what we need to do next is to just take the common factor between these first two terms that are there. So the common factor between these two is going to be 4b, So we're going to have 4b, we're going to take it out. If we take 4b on this one, we're going to be left with b, and then on this one, we're going to be left with hopefully 2, because 4b multiplied by 2 is going to give us negative it's going to give us negative 8b, perfect. So we also have to do the same thing also on this one. We need to take out the common factor. So the common factor I think is a. We're going to take also the negative out, so we're going to have negative a. And if we take negative out, it's going to be left here. We're going to be left with this b, and then on this one, we're going to be left with this 2, So we're going to be left with b. Remember, we have negative here. So this negative, it has to be, this one is going to be negative 2, such that when we multiply this together, it's going to give us this positive 2a that is there, perfect. So once we reach this kind of a point, we also have a common factor on this, because we treat this one, if you pay close attention, this is the first term, this is the second term, because they are separated by that negative sign that is there, So between these two terms, we have a common factor. Something that is common between these two is this b minus 2 and b minus 2. So we can be able to take it out as our common factor. So we're going to take it out, b minus 2. So if we take b minus 2 on the first term, what is going to be left? We're going to be left with 4b. And if we also take this one here, it's going to be left, we're going to be left with negative a. And with this, we are done with our question. Let's move on to the next one. So now let's just take a look at this 1.3. They say factorize full, which is also worth 2 marks. How can we factorize this one? So if you pay close attention, guys, this is still the same as a trinomial. This will be the same even if we have, this is the same as like this actually. Let me just write it down. Plus 4, It just happened that on this one, they just use the letter V instead of X, So this is still the same thing, perfect. So how can we factorize this one? So there's a lot of method that a lot of people do, but for me, I prefer this one. So what we do here to solve this one, it does not have a coefficient of 1. What can we do? We can just take this one and multiply with this. So this is going to give us 20, which we say 5 multiplied by 4 is going to give us 20. So what we need to do next is to find the factors of 20 that when we subtract them or add them together, it's going to give us this negative 12 that is there, perfect. But before we do that, we need to drop this one the way it is and also this one the way it is. So we're going to have 5v squared, and we also drop this positive 4 that is there. And then those kinds of factors we're going to find, we're going to just fill them here, and when we write them, we're going to write them with letter V with them, So the factors of 20 that when we subtract them together is going to give us negative 2. It's going to be 10 and 2, because 10 multiplied by 2 is going to give us negative actually. Negative 10 multiplied by negative 2 is going to give us 20. And when we say negative 10, negative 2, we're going to still get negative 12. So I'm going to just put them here, negative 10v and negative 2v, So next, now we're just going to just group this by, we're just going to factorize by grouping, just like the same question that we done on 1 point, I think it was 1.2, something like that. So we're just going to group this 5v squared minus 10v minus 2. We're just going to, let me just write it like this, plus 2v plus 4, So I'm going to just take out the common factor. It's going to be 5v, then we are going to be left with v minus 2, and then here our common factor is going to be negative 2, and then we're going to be left with v minus 4. When we multiply this, we're going to get this one, and when we multiply with this, we're going to get positive 4. So we also have a common factor, which is this one and also this one. And then you're going to have v minus 2 as a common factor, and I'm going to be left with negative 5v minus 2. So this is how we simplified this one. So the last question of question 1 is this one. It's 1.4. This is simplify, which is worth 6 marks. Guys, here you need to be very, very, very careful whenever you're dealing with this. So if you pay close attention to the first one, which is here to our numerator, actually, we have a difference of cubes there. How do we deal with a difference of cubes? This is difference. Let me just write it down here. How do we deal with the difference of cubes? If you don't understand how to deal with this one, please check out our videos. So what we do, we're just going to open two brackets like this, the smaller one, the bigger one. And then here we're going to just put the cube root of this number. It's going to be x. So it's going to be x now. So we're going to have x here. And then the number that we put here is going to be the cube root of this 3, of this 8, which is going to be 2. So you're going to have 2. And then the number that we put here is going to be the square of this number. So we're going to take this variable, just square it. So we're going to write it here after we find that kind of number, which is square. And then the number that is going to be there at the last is going to be also the square of this one. It's going to take this and square, which is going to give us 4. And then the one that is going to be here, the third one, is going to be the multiplication of these two, which is going to give us 2x. So you're going to have 2x. So what about the signs? For the signs, we use what we call the SOAP method. This S stands for the same sign, and then O stands for the opposite sign. And then this SOAP, now SOAP, just like this. So this AP is going to stand for always positive sign. So how do we work out with this one? So for the same sign, we're going to just take the same sign the way it is, and then we'll put it here. And then the second one that we're going to put is going to be the opposite of what of this one that is here. So you're going to have positive instead of negative. And then the last one is always positive sign. So we're going to put the positive sign here. So to factorize the one at the top, we're going to have the following, which is that one, perfect. So now we're going to the denominator of the first term. How can we deal with that one? So this one, I want you to be very careful. We have 4 minus x squared. A lot of teachers, they don't think that there is something wrong with this. But for me, each and every time, whenever I tell my students just to put this kind of equation in a standard form, is going to help you a lot. So here, we can put this in a standard form by starting with this one and ending with this one, So I'm going to start with negative x squared and we'll end with 4. Why? Because this is still the same thing. Remember, when we have, for example, let me just give an example. If we have 2 minus 1, this is still the same thing. This will give you 1. This is still the same thing if in one we have negative 1 plus 2. Even if we start with this and we end with this positive 2, we're still going to get 1. You can try this using your calculator there, perfect. So for this one, the reason why I'm doing that is I want to put our equation because we are not used to have something like 1 minus x. No, it's not in a standard form. So we need to put it in a standard form first. So after putting it in a standard form, we just need to take out the common factor, which is the negative. So I'm going to put negative outside. And then what will be the number that we can be able to multiply with negative 1 to give us positive 4 is going to be negative 4, just like that. So downwards, we're going to have negative, open brackets, x squared minus 4, just like that one, perfect. So now we can be able to move on to the second one. Remember, here we have multiplication. So the one that is at the top is already simplified, and then going downwards. So this one, we just need to take out the common factor there on it. The common factor, I think, is 3. So if we take 3 out there, let me just try to zoom it in so you guys can see. So we can take 3 out there. If we take 3 out on the first term, we're going to be left with x squared. And then if we take 3 here, we're going to be left with plus 2x. And then the last one is going to be plus 4, perfect. So that one, I think it's going to make a perfect sense then, right now. So what can we do next? Remember, guys, this is an operation of multiplication. When we have, for example, 1 over 2 multiplied by 3 over 4, this is the same as 1 multiplied by 3 over 2 multiplied by 4. When we are multiplying, the numerator goes with the numerator, the denominator with the denominator. So quickly we can just do that and see what is going to happen there. So I'm going to have x minus 2, x squared plus 2x plus 4, which is divided by negative x. Oh, this one that's at the top, this is a difference of squares, guys. Now, this one, let me just highlight it. This is a difference of squares. We can just simplify it right now. So I'm going to put that negative aside and we'll open two brackets. Going to have x squared 2x, not x squared, minus n plus 2. This is a difference of squares. You can just simplify it like that, but we must not forget the negative outside. So since we're multiplying there, so we're going to multiply what is at the top, which is multiplied by x plus 2, and we'll multiply what is at the bottom, which is 3x squared plus 2x plus 4, So if we reach this point, you can see now that this is the same as this, and this is the same as this one, and then this is the same as this one. So what is going to be left if we cancel out that one? So at the top, we're going to be left with 1 in the numerator. At the denominator, we're going to be left with this negative and what? And also this 3, So it's going to be negative 3, which is going to be our final answer for this one, So yeah. So now we're moving on to question 2. So question 2, it also carries almost 20 marks on it. Let's just quickly start with 2.1. So 2.1, they say solve for x, which this one is worth 4 marks. How can we solve for x from this one? So for this one, we can just first try to put this in a standard form such that we're going to have a quadratic, a trinomial actually, So we're going to have x squared plus 2x, and then we'll take this one to the other, so it's going to be minus 15, which is equal to 0. So what we need to do next, this is a quadratic formula, this is a quadratic equation, So we're going to open two brackets just like this, which is equal to 0, and we'll put x here and x here. So now we're going to look for the factors of 15 that when we subtract them together or add, when we multiply them, those kinds of factors, it's going to give us 15, but if we subtract them or add them together, it's going to give us 2, We're going to look for the factors of 15 that when we add them or multiply them, when we multiply them together, it's going to give us 15, but when we add or subtract, we're going to get a 2. So the factors of 15 is going to be 5 and 3. So we're going to have 5 here and 3 here. Let me just use that one. Okay, yeah, good. You can see. So we're going to position them in such that we're going to get what they're looking for. So we're going to have negative, not negative, actually, we can just say 5 minus 3, because this would give us that 2. And then when we say 5 multiplied by negative 3, we do get negative 15. So you're going to have positive and you're going to have negative. So now, a common mistake that I saw in a lot of my students when they reach this kind of point, they're just going to just went back and just take this one, multiplies here and no. If you do that, you're going to just get back to where you are coming from. So here, just going to use the zero factor law. The zero factor law is that when we have something that is multiplying each other just like this, and we have 0 at the end, we're going to equal each and everything that is inside the brackets, equal it into 0. So we're going to just say x plus 5 is going to be equal to 0, or x minus 3 is going to be equal to 0. Our x here is going to be equals to negative 5, or x is going to be equals to 3. And with this one, we are done, and we take that kind of 4 marks for free. So moving on to 2.1, they say solve for x, which this one is 3 marks question. So this is an exponents question. It's an exponential equation, actually. How can we deal with this one? So here we need to make use of what we call the law of equality, So the law of equality says that when we have same bases, just like this, and AM, for example, if the bases are the same between equal sign, we can just simply equate the exponent and equal it into this, So in order for us to solve this exponential equation, we just need to try our best to make these basis the same, because once they are the same, we can be able to just like drop the exponents that are there and solve for x, because we have an exponent of x there at the top. So before we do that, there we need to divide both sides by this 3. So we can divide here by 3, and we'll divide there by 3. So this one's going to cancel this. We're going to be left with 2x which is equals to, so 48 divided by 3 is going to give you 16, and then still if we just take a look at this one, the bases are not the same between the equal sign. What can we do? We can just simply change this one into its prime base. What we're going to do is going to take out the calculator, just press 16, press equal sign, press shift, and press this button called fact there. If you press this on your calculator currently right now, you're going to get that on the other side, you're going to have 2, which has an exponent of 4. So now if you pay to attention, we do have the same base. Once the bases are the same, we can just simply equate the exponents. So our x here is going to be equals to 4. So this is how we solve for x for this 3 marks question. 2.2 is that solve for x and y simultaneously, which this one is worth 4 marks. So this one is worth 4 marks because you can simply use elimination, and it is very, very easy if you use the elimination method. But for me, I always teach substitution. The reason why I always teach substitution to my student is because substitution is the one that you're going to use mostly in grade 11 and grade 12, So I want you to practice using it now while you're in grade 10. So what we're going to do to use the substitution method, we're going to name this equation. So this one we're going to name it equation 1. This one we can name it equation 2, So from these two equations, we're going to pick one equation that it seems a little bit easy for us to solve x or y. From these two equations that we just named here, we're going to pick one equation that it seems a little bit easy for me and you to just solve for x and y, So both of them are easy. I can simply pick one just for the record. And you can just simply say from equation 1, what does equation 1 say? Is that x plus 2y is equal to 4, and I can make x or y subject of the formula. For this one, I can make x subject of the formula. So I can just simply say x is equals to 4 and take this one to the other side. It's going to be minus 2y. So I can call this one equation 3, So my next step that I'm going to do, I'm going to sub equation 3 to the equation that I have not yet used between these two equations. So if you pay close attention, to create equation 3, we use the equation 1. So the one that is not yet used is equation 2. So that's what we're going to do right now. We're going to substitute equation 3 to the equation that we have not yet used, which is equation 2. So we're going to substitute it into equation 2. And you might be asking yourself right now, grade 1, what are we going to substitute in equation 3? Actually, what is our equation 2? Our equation 2 says that 3x plus y is equal to 7. What are we going to substitute in equation 3? Simple. We're going to just, whenever there is x, we're going to substitute this 4 minus 2y, So whenever there is x in this equation, we're going to substitute what is there. So here we're going to have 3, and open brackets, we're going to substitute this 4 minus 2y, and then plus y, which is equal to 7. So now, if you pay attention to this equation that is here, we only have one variable to solve, which is we're going to solve for y currently for that one. So here we can just simply distribute this multiplies here and also multiplies them. So 3 multiplied by 4 is going to give us 12, and 3 multiplied by negative 2 is going to give us negative 6y, and then plus y, which is minus, I can take this one to the other side, it's going to be minus 7, which is equal to 0 then. So now I think I need to just group the like terms. So this and this are the like terms. 12 minus 7 is going to give me 5, which is going to be 5. Negative 6 plus 1 is going to give me negative 5y, which is equal to 0. And then from here on, I can just solve for y. There's a lot of ways to do this, but the first one that I see, I can take this one to the other side, which is going to be positive y. Then I divide both sides by 5. Then my y is going to be equals to 1. So since now I found the value of y, I need to find the value of x. So I'm going to just sub y into equation 3. What does equation 3 say? Equation 3 is this one, so that x is equals to 4 minus 2y, So whenever there is a y, I'm going to substitute this on my equation 3. So I'm going to have x which is equals to 4 minus 2, and then my y is 1. And then if you punch this in a calculator, you're going to get that your x is going to be equals to 2. So this is how we solve the simultaneous equation for this question. So moving on to the question 2.3, this is solve for x, show your answer in the number line if that inequality that is there, So this is an inequality question, and there's a lot of marks, which is 5 marks. How can we solve this one? So when we're solving this, you need to be a little bit strategic, or you need to know some few basics. If you don't know how to deal with inequalities, please check out these videos. It's going to help you understand what we're going to do here. So what we're going to do here, we're going to isolate everything that is inside here, and we'll leave x alone. Everything that is inside there, that is between those kinds of negative 16 and 22, we're going to take it to the other side. So what I'm trying to say to you is that we're going to take this 2 first to the other side, but mathematically, what you do on the left hand side, you have to also do it in the right hand side. So when we take this 2 to the other side, we're going to also take it to the other side there. Remember, an inequality is the same as the equal sign. So each and every number jumps the equal sign. It has to change the sign that it has originally. So we're going to have negative 16 here. When we take this 2 to the other side, it's going to be negative 2, which is the inequality. We keep it the same. So when we take this one to the other side, we're going to be left with negative 6. This negative 6 there inside, and we're going to keep the inequality the same. And what we do, since we take this one to the other side, we're going to take it also to the other side. So we're going to have 22 minus 2, So we just need to work on the left and also on the right hand side. So here we're going to have, if you punch in a calculator, we're going to get negative 18. We keep the inequality the same, 6x, and then this is going to give us 20. And the next, we're going to divide both sides by this negative 6. And this is something that you need to know. Whenever we're dividing an inequality with a negative number, the sign of an equality is going to change. For example, if we have negative 2x, which is greater than 1, if we divide by a negative number both sides, this inequality sign is going to change. You're going to be left with x, which is less than negative 1 over 2. This inequality is going to change whenever we divide with a negative. So that's a little bit reminder you need to know. So we're going to do it here. We're going to divide both sides by negative 6 and negative 6 and negative 6. So if you divide this one down, that's going to get 3, which is this sign is going to change. This one is going to change. It's going to look on the other side. It's going to be like this. And then this one is going to cancel each other out. We're going to be left with x. So then also this inequality is going to change. It's going to look on the other side because we divided by negative. So we're going to be left with 20 over negative 6, because this one, if you calculate, they're going to still get the same thing, So when we're dealing with inequality, you need to understand the following. You need to put this in a standard form. A standard form is whereby you're starting with a smaller number and end with the bigger number, So this one is the smaller number and this one is the bigger number. So I'm going to start with the small and end with the bigger. So I'm going to have negative 20 over 6, and then put this one, and then we just put it like this, and x, which is 3 on the other side. Let me just quickly demonstrate what I just did here, because some of you may be wondering, what have you done, man? What is this? If you pay attention, let me just try to paint this so that you can be able to see what is happening. If you just take a look at what is there, this is still the same as what is here currently. This, it means that x is greater than 20 over negative 6. Also, this one to say that x is greater than or equals to negative 20, So it means that what I've done there is still the same thing, nothing that has changed, Also, if you pay attention to this that is here, it's still the same as this thing that is there. This, it means that x is less than 3, and also this, it means that x is less than 3, So I just put it in a standard form whereby I start with a smaller number and end with the bigger one, Yes. So now we need to represent our answer in the number line. This is very, very easy. What you need to do is just going to just draw a number line like this and start with the smaller number, which is negative 20 over 6, and we're just going to put 3, and then you're going to put this round thing and this round thing there. So something that you need to know is that when we have equal to, we need to shade this point that is here. So on the number, I'm just going to just demonstrate to them where do we find our solutions. So these things mathematically, I always explain to my student, whenever you see these two things like this, it means in between. This is just the illustration of saying in between, in between, or your solutions are found inside these numbers that's going to be here and also here. So our solution are found between negative 20 over 6 and 3, so they are not found on this other side and they are not found on this other side. They are found between these two numbers. So we're going to shade that kind of a part. We're going to go there. So it's found between these two numbers. So this is how you will represent this in a number line, and then for that we're going to take this full 5 marks because we are done with it. So moving on to 2.4, they say a mother is at the present 9 times the age of her daughter. In 3 years' time, the mother will be 5 times her daughter's age. What are the present age of the mother and her daughter? So these type of questions, guys, they are very, very, very tricky because they don't teach this at school. You're just going to find them in your exam, just like this one, perfect. But don't worry, guys, I've made videos about this. These are the part of a math modeling chapter. There is this playlist of exponential equations that I've made. Check out this video on the screen right now that talks about this age and weight problem. You're going to understand it a lot because on this question, whenever I'm going to explain in the following, if this is your first time doing this type of questions, it's not going to make sense for sure unless you are just a little bit good in math. But if this is your first time, it's not going to make sense. For this kind of question to make sense, please watch this video because I've demonstrated a lot of example there, perfect. And it's a must. You must know this type of questions before you go to write your exam. So how do you tackle this type of questions? You need to understand how to make an equation out of the ways. This is the type of math modeling questions which I also have a playlist of. So let me just stop the yapping and just concentrate on how we're going to deal with this. So we need to create an equation, guys, and the way that I always attack this type of questions is the following. I use the table to just create an equation here and understanding what is happening here. So if you read the first line here, which is this one, it talks about the present moment. They say a mother is at the present 9 times the age of her daughter. So this is for now, actually, this is for now. And then this one, it says in 3 years' time, the mother will be 5 times old. This is for future, actually, So we need to create an equation. The way that I do it is just to use the table, So we're going to talk about, I'm going to make a table of a mother. This is going to be a mother and also a daughter, actually, a daughter. And then I also have to create an equation for both of these, and then we have a present moment, and we also have a future, which is future there. So let me just make this table. So if you use this table, guys, it's going to make sense a lot what is going to happen here, So what I like to do is to first read what is happening here. They say a mother in the present moment is 9 times an age of a daughter. A lot of my students, when they are tackling this type of questions, they conclusively say, or they assume that the mother is 9 years old. No, that's not what they're saying here. They say a mother at the present is 9 times, not is 9 times, is 9 years old, is 9 times the age of a daughter. In other words, right now in the present moment, we don't know the age of the mother and we also don't know the age of the daughter. So if we don't know something in mathematics, we can just let it be equals to x or y. So for the mother's age, I'm going to let it be equals to x, and for the daughter, I'm going to let it be equals to y, because the present age of daughter and the mother, we don't know it. I'm just going to let it be equal to x. So how is this first paragraph going to be helpful to create our equation? We're going to just read it through and understand. They say a mother is, So what is the mother's age right now? The mother's age currently, we don't know, but we'll let it be equals to what? To x, So is, mathematically, is equals to, is the equal sign, whenever there is, it means equal sign. So mother is 9 times, is 9, this mother is the 9 times, it's 9 times the age of a daughter. What is the age of a daughter currently? Currently, which is the present moment, is y. We don't know it. So it's 9 times. I'm just going to just multiply by y. So multiplying it by what's the same as when we have like 9y, just like that one, Perfect. So this first paragraph that is there, it helps us to create the first equation. This x that is here is for a mother's age that we don't know, but we know that is 9 times the daughter or his daughter's age, which is y. Perfect. So let's move on to the future. For the future, how old will be the mother? If his age right now is x, how old will he be in future? Because they say in 3 years time, they say in 3 years time the mother will be 5 times the age of his daughter. So how will he be his age in 3 years time? We don't know his current age, but how old will he be in future? So this question that I'm asking you right now is the same question if I ask you like this. If now, let's now assume this is you currently, and then currently, how old is the grade 10 learner? Let me just think. I think 15. Okay, let's say now you are 15 years old currently. Now you're 15 years old, and I ask you, this is the question I'm asking you right now. If now you are 15 years old, how old will you be in 3 years' time? How old will you be in 3 years' time? If now you are 15 years old, in 3 years' time, you're going to be 18 years old. But what I want you to pay to attention is, how did you get this 18? You take your current age that you have currently and you add with the future that I'm just promising you or asking you to. I ask you, if now you're 15 years old, how old will you be in 3 years' time? You just take the current age and you add it with what? With the future, which is 3, which is going to give you 18. So this is what we're going to do basically here. The age of the daughter of the mother is x. We don't know it. So the current one that is the same as you, which is 15, is going to be x. For the mother currently is going to be x. And I'm going to add it with what? With the time that is going, that talking about the future. They say in 3 years' time, so I'm going to add 3 for his future's age. If we know the value of x, we'll just know his age. But for now, we're just going to just put it as x there because we don't know anything about that. So now let's just move on to the daughter. For daughter, we're going to do the same thing. We're just going to take his current age, which is y, and then let me just use the red one. It's going to be y plus 3 years time, perfect. So now going to the equation. We're just going to use what they've told us there. So they say in 3 years time, the mother in 3 years time. How old is the mother in 3 years time? Is x plus 3. So I'm going to just say x plus 3 is equal to, because they say the mother will be, which means equal to, will be 5 times her daughter's age. Will be 5 times a daughter's age. What is a daughter's age at the future? It's going to be y plus 3. Guys, don't worry if it does not make sense to you right now. It's because this is your first time doing this. Be patient with yourself. These questions are very easy. They just need you to practice more of it. You're going to understand what is going on. So now I'm going to, since now I have the equation 1, which is x which is equals to 9y. This is going to be equation 1. And I also have x plus 3, which is equals to 5y plus 3, which is what's going to be my equation. So now I'm just going to just solve a simultaneous equation, perfect. So how I'm going to do that is very easy. Whenever there is y, there is x on this second equation, I'm just going to substitute 9y, because I say x is equals to 9y. So whenever there is x, I'm going to just put 9y plus 3, which is equals to, and I distribute this, is going to be 5y plus 15. So now I can be able to solve for y. Remember the question, you want to know the present age of both mother and child. So you're going to just group the like terms. 9y minus 5y is equals to 15. I take this one, that's going to be minus 3. And then let me just do it here. This is going to give me 4y, which is going to be, this is going to be 12. So I'm going to divide both sides by 4, and then y is going to be equals to 3, So the y is the age of what? Is the present age of the daughter. So the daughter is 3 years old. So what about the mother, which is x? So I'm going to use this equation here. So I'm going to just say sub y into equation 1, which is, I'm going to just say x. Whenever there is y, I'm going to substitute this y that I got right now. It's going to be 3. X is going to be 9 multiplied by this, is going to give us 27. So in conclusion, we can just conclusively say that the mother is currently 27 years old and the daughter is 3 years old. And then we are done with this 5 marks question. It can sound a little bit difficult, but don't worry guys, this is your first time. Be patient with yourself. Please check out this video that is there on the screen right now. Go and watch it. It's going to help you a lot. So now we are moving on to trigonometry, which is question 3. So this one carries only 8 marks on it. So yeah, let's just quickly start with the first question. So by just seeing this before we move on, they say in the diagram below, point P, which is this one, is given, and is the theta, which is the theta that they are referring to. They are referring to this one that is there, is between 90 and 0 considered. So then they say answer the following questions without the use of a calculator. In other words, what they're trying to say is that don't use a calculator, but use a diagram in order for you to answer these questions. So the first one, they say calculate the length of OP, So let me just slide this so that I can be able to have space to write. So if you pay close attention, OP is this side that is here, how can we find it? So we need to draw our diagram. Just have to finish this the way it is. Then let me just finish it correctly. Just like this, and then here we have a 90 degrees angle. Remember, this point here is an x value and the y value. So the x value is going to go this side, and then the y value is going to go that side. So the OP that they're looking for here is what we call the hypotenuse, So we're looking for the hypotenuse. So we're going to use the theorem of Pythagoras. So the theorem of Pythagoras, it goes as follows, whereby the R is the hypotenuse, or is the OP that we are looking for, which is OP squared. And then the x is this x value that is here, which is 4. So it's going to be 4 square plus 3 square. So then next I'm going to just square root both sides so that I can be able to have OP, not OP square. So then OP is going to be, if you purchase a calculator, you're going to get 5 units, Yes, 5 units. So the value of OP here is going to be 5 there, perfect. So now we can be able to move on, and we'll take that 3 marks. 3.2, they say calculate the value of sine theta, So in order for us to calculate this, we need to make use of what we call the SOHCAHTOA method. And again, I'm repeating to you this, guys. If I also have a playlist of trigonometry for grade 10. If you don't understand some of the things that I'm going to explain here, please check out those kinds of videos. Do a revision of it before you come to this type of questions. So sine by definition is equal to the opposite over hypotenuse, So the opposite on our triangle here, what is the opposite here? The opposite is the opposite of this angle. So this is going to be the opposite. And then the hypotenuse is the one that faces the 90 degrees. The adjacent is going to be this one, So I'm going to find those kinds of values. Remember, when we are finding the value, avoid this. I saw a lot of my students doing things like this. They're just going to say sine, and then they open brackets, and then they write that kind of value. No, you are not required to do it in that kind of a way. So what do you do? For sine of theta, just going to just write it as a definition. Is equal to the opposite over hypotenuse, So what is your opposite on a triangle that is there? The opposite there is 3, and then the hypotenuse is 5. And this is the value of sine theta, So moving on to cos. Also, for cos, we're going to just go it with the definition. It's the adjacent over hypotenuse. So it's the adjacent over hypotenuse, which is equals to, what is the adjacent? Is 4 over 5, So this is our value of cos of theta. So let's go to the last one, which is this one. So they are looking for the value of sine squared theta plus cos squared theta. So this is very, very easy, given that we already have this and also this. We're going to make use of it, but here you just need to put the square aside. So here we're going to have like this. So we're going to just open two brackets just like this, and we'll put those kinds of square. We'll put those kinds of definition. Sine is the same as opposite over hypo. I'm just writing it for the sake of, for those who don't know. So, and then cos is the same as adjacent of hypotenuse, and then the value actual of cos without the square is 3 over 4. It's going to be 3 over 5, square plus, and then for adjacent it's going to be 4 over 5 square. So here for this 3 marks, you need to show your calculations, guys. Don't be in a hurry to just patch it in your calculator. Show all your calculation, because they're going to just want to see each and every step. So to continue with this, what you need to do in your calculator, punch this in a calculator alone, and also punch this in your calculator alone. So if you punch this in a calculator, you're going to get a 9 over 25. So let me just continue it here. 9 over 25, and then plus, if you punch this one, you're going to get 16 over 25 also, So this is the one. This is just a matter of understanding the fractions. So we're going to add this together. No, we're going to keep it the same. We're going to keep the denominator the same because it's the same, and then we say 9 plus 16. Or now you are allowed to punch this in a calculator if you want to, if you don't understand any of the fractions. So next, 9 plus 16 is going to give me 25, divided by 25, which is going to give me 1 as an answer. So this is how we master this 8 marks question. So going to question 4, they say use a calculator to find the following correct to 3 decimal places. So this type of questions are very, very, very easy, guys. All of them, you're going to just make use of your calculator. Let me just bring out my calculator. So here's my calculator. So what I need to do, just have to punch this the way it is, It's 3 multiplied by sine of 138. And then I get the answer. The answer is 2,007. This I must round it into 2 decimal places. It's going to be 2. And let me just use this pen. It's going to be 2,007. They say I must leave it into 3 decimal places. So this is how we're going to do this for 1 mark. And for the second one, this one is sec 50. Remember, sec is not in our calculator. Just look at, there's no sec in our calculator. Is it sec there? No. So, but we know that this, what is this actually? This is the reciprocal of cos. How do we know that? We just look at the third letter of this. So this is the same. Let me just write it here. This is the same as 1 over cos of 50, So this we can be able to punch it in our calculator right now. So now we're going to punch this in the calculator. which is going to give us 1,55. They say we must run it into 3 decimal places. It's going to be 1,556, So here our answer is going to be 1,556, and we are done with this one. Let's check out the last one, which is they need the value of 40. Okay, for this one, you need to be a little bit very careful first on how you're going to handle the square that is there, So let's just first try to put it. We're going to have 4. This is the same as tan 2288, 2, and then we have square. This square in your calculator, I'm going to put it like this and then multiply. This one's the same. So what I've done here, just demonstrated how you're going to put this in your calculator. So we can just punch it in our calculator right now. Let me just put absolutely everything. So here's my answer. Just look at how I've done it in a calculator. This is how you're supposed to do it. So this was going to be negative 1,8,336, 717, because they say we must leave it into 3 decimal places. So I think this is how we're done with this one. So the next one, they say determine without the use of a calculator, guys. Here they say that we must not use a calculator to find the value of cos 30 plus tan 30. If you remember very well, 30 are what we call the special angle, the special angles. The special angles are 30, 45, and 60. These are called special because this is the only angles in trigonometry that we are allowed to use a calculator. This kind of, like we are using this kind of triangle, like your teacher may have taught you this by that each and every time you must use a triangle to answer them. But I'm telling you, some examiners don't care about this. I see a lot of memorandums, they don't care if you use a calculator or not on the special angles, because they assume that each and everyone understand the special angle. So for this one, what you need to do is they say that you must not use a calculator. The thing that you must not do here is to punch this in a calculator and it gives you the answer. No, what you need to do is to punch this piece by piece. For example, we're going to take out our calculator, which are going to just say cos of 30, which is going to give us root 3 over 2. Don't write it in the decimals, but write it in the fractions. This is going to help you to get those kinds of marks. So I'm going to have root 3 over 2, which is plus. And then for tan 60, we're just going to punch tan 60 in our calculator. Is going to give you root 3, perfect. So what you need to do next here is just to try to simplify this piece by piece, So for this one, you can just try to add them. Let me just check the marks. Yeah, I think the first mark is going to be for this one, the third one, the second one, then the second one is going to be for answer. But just because of playing it safe, you just need to pretend as if we're not using a calculator. So we're going to divide this by 1 so we can be able to make up our fractions. So I don't know if you guys understand how to make fractions, but we can rationalize this one. We can have 3 over 2 plus, we want to make this denominator the same, because once they're the same, we can be able to add the numerator. So the LCD is 2, so we're going to multiply the top one with 2 and also multiply the bottom one with 2, So what I've done is this is the same as if I multiply it with 1, or the same as if I done it like this, divide by 2, So this 2 multiplies here and also multiplies there down. This is the same as 1, This is called the rationalizing. If you don't know this, don't worry, I also have videos about this. So what we need to do, since now the denominators are the same, we can keep it the same, and then we add what is at the top plus 2 root 3, perfect. So next year, and I'm telling you guys, these steps are not necessary for your answer. You can just punch it in a calculator. After doing this, you're going to get those kinds of full marks. But for those who want to play safe, let's just play along. So this one, you can punch it in a calculator. It's going to give you, I think, 3 over 3 over 2. This is going to be your answer. So this is how we did with this one. Let's move on to the next. So even 4.2, there's a determine without the use of a calculator. What you must avoid here is to take your calculator and punch all this. You're not going to get marks. This is a 5 marks question. You need to be very, very careful. Remember, 45 and 30, these are the special angle. You are allowed to punch them in your calculator, or you use that kind of a triangle that your teacher has taught you. But for my student, I always tell them, use a calculator whenever you say a special angle. A special angle is 30, 60, and 45, So for this first one, I'm just going to make use of our calculator here. So we're just going to say sine of 45, which is sine of 45 is the same as root 2 over 2. So here we're going to have a root 2 over 2 for sine of 45. What about cos of 45? So cos of 45 is the same as root 2 over 2. Root 2 over 2 minus, we need to change this because it's not there in our calculator. So this is going to be 5. This is a reciprocal. Which reciprocal of which trig ratio is the reciprocal of cosec? So the reciprocal of cosec is sine. How do we know? Just check at the third letter there. So we're going to have 1 over sine 90, or sin. Some of them, they call this sin. Whatever, still the same. So this, we're going to put it like this, and then we're going to have plus 3. Let me just remove my calculator. So for this one, you need to be very careful when you're putting in a calculator. We're going to have, and let me just expand it so that you can be able to see. So I'm going to just say 30, and we'll put squared there on our calculator so that you can be able to get. Now, actually, there's no need to do it in this way. We can just simply patch tan 30 here. Let me just put this here. Tan 30 is root 3 over 3. So we're going to just have a root 3 over 3, and then we're going to have square there. Don't forget, this square is for there, perfect. So from here on, this one, guys, for this one, you can punch it in the calculator, because it's going to give you 1 if you see it, because they're the same. Numerator and the denominator are the same. So this one is going to give us 1, and then minus 5. So let's just try to punch this in the calculator. So 1 over, I think this one's going to give us something like 1. Let's just try it out. Yeah, it's still going to give us 1. So this is 1. Okay, plus, and then let's see this one. So this one, you're allowed to also punch it in your calculator. No one will notice this, guys. In trigonometry, guys, whenever they say you must not use a calculator, they're not merely saying you must use your brain for all of this type of stuff. They just want you to show step by step how you done your things. So this one is also going to give us 1. This we're going to get 1 there. So we're going to be left with this. So I think even this one, you can punch them in your calculator and find the answer. This is 1 minus 5 plus 1, which is going to give us a -3 as our answer here. So going to get -3 as an answer. So this is it for this one. Let's move on to the next. So the next one, they say determine the value of theta by using a calculator if theta is between 0 and 9. So this is they are called the trigonometric equations. This one, how do we deal with them? They're very, very easy. So since here we have tan theta, which is equals to 4,96. So I'm just going to say theta, which is equals to tan inverse. And then we're going to put this number that is here, So just going to punch this on a calculator. Take out your calculator there. So this button is this one that is here. Just going to press shift and press this tan. And then you put at 4,96 close brackets. So it's going to give you 78,60. So this is going to be our answer. So moving on to this one. So even this one is the trigonometric equation. What we need to do first here is to first divide by 2 both sides. So we're going to be left with sine of 2 theta minus 10, which is equals to 1 over 2. So since now we have this, we can be able to use the reciprocal. I'm just going to say 2 theta minus 10 is going to be equals to sine inverse, and then we're going to have 1 over 2. So then 2 theta is going to be equals to sine inverse, I think this is 30. Sine inverse, and we'll put 1 comma 5, 1 comma 2, which is 1 comma 2. Look at this. Yeah, I think it's 30. This is going to give us 30. This one is going to give us 30. Now going to take this one to the other side. It's going to be positive 10. So you're going to be left with 2 theta, which is equal to 40. So since now we're solving for theta, we can divide both sides by 2. And then our theta is going to be equals to 20 degrees. So this is how we deal with this one. So moving on to question 5. So this kind of question, I was trying to look at it. It is mixture of what do they call this? There's these things they call 3D and 2D dimension in trigonometry, and also it mixes something with Euclidean geometry, So some of the stuff that they're going to apply here is part of the Euclidean or something like that, But it's trigonometry also. They say in the following diagram, angle B is equals to 22. Angle B is what is this one? So it means here is equal to 22 degrees. And they say BD is equals to 10. So this one is 10 centimeter. And then they say write down 2 ratios representing sine angle A. So this is the same as when they're saying sine A, actually angle A, that referring to this angle that is there, So they want us to give us them the ratios that will give them this in this triangle this here. So if our reference angle is here, we have this triangle that is 90 degrees here. So sine by definition is equal to the opposite over hypotenuse, right? So which ratios here that are going to be equal to the opposite? If our reference angle is here, so opposite is going to be this DC. So going to have DC divided by the hypotenuse is going to be AC. So this is the first one. They need 2 of them. So we also have sine of A on the what? On this bigger triangle that is here. If our reference angle is here, this is going to be the opposite. And then this is 90 degrees, this is going to be our hypotenuse. So another trick is going to be BC, which is BC divided by hypotenuse is going to be AB. So these are the ratios that are representing sine A or sine angle A. So for that, they're going to give you 4 marks. So the next one they say, let me just erase this a little bit so they can be able to understand what is going on. And also this one, because you did get it. So they say show that DC is equal to 4,04. Remember here we have 22 degrees and here we have 10. They want us to show them that this DC that is here is equals to 4,22. So how are we going to solve this one to find what we're looking for? So if you pay close attention here to what we are given, we can be able to make use of trig ratios to find that missing side that is there, which is DC. We can be able to make use of our trig ratios. But how though? How are we going to make use of our trig ratio? We need to understand that. We need to understand this. This, let me just show you. This, since here is 90 degrees, it means even here is also 90 degrees. So just going to say first, we need to detail this. I'm going to say angle B DC is equals to 90 degrees. The reason why we say so is because sum of angles on a straight line, So this is the reason. So this one is equal to 90 degrees. So in other words, we can be able to make use of this triangle that is here to find what we are looking for, So we have this angle here, and then we have this side, which is 10, and then we're looking for DC, So we need to figure out what are these sides actually in this triangle. Are they the opposite or hypotenuse or what? So if our reference angle is here, this is going to be the hypotenuse, this is going to be the opposite, this is going to be the adjacent. So what are we given here? We're given the adjacent, then we are looking for the opposite. So which trig ratio talks about that? The opposite and the adjacent is going to be tan. So we're going to make use of our tan. So we're going to say tan of B, which is of angle B, is equal to what? To the opposite over adjacent, So tan B, we know they've given us is equals to 22, and then our opposite here is DC that we are looking for, and then this one is 10. So just going to cross multiply this. DC is going to be equals to 10 22 multiplied by 10. So DC, if you punch this in your calculator, going to get 4,04 centimeter. So this is what they were trying to ask you. They wanted you to just show them that DC is equals to 4,04 centimeter. So let's move on to the next question. So the next question, they say write down the size of sine DCA, which is 2 marks. Let me just try to do this in a different one. So they are looking for, we need to first understand this. They are looking for sine DCA. In other words, they're looking for this angle that is here. So D, which is DCA, they're talking about this angle, actually, this angle that is here. They want that kind of an angle. Remember, here we have 22, and let me just, here we have 22. And how can we find this DC actually? There is a lot of ways that we can be able to use to find this DC. But one that I can be able to say is to make use of our Euclidean geometry knowledge, Yes. Because we need to first find out what is the size of angle DCA. So since here we have 90 degrees, we can make use of a sum of angles in a triangle to find angle A, So we can say angle A plus angle B plus angle C, that is that one, is equals to 180 degrees. Why? Because this is a sum of angles in a triangle, So angle A, we are looking for it right now. And then plus angle B is 22 plus angle C is 90, which is this one. This is 90, which is equals to 180. So angle A is going to be equals to 180 minus 90 minus 22. Angle A is going to be equals to 68. Yeah, hopefully it's going to be equals to 68. So now we did find this one. Let me just erase and try to zoom it in. So this one is equals to 68, this one. So if you pay close attention, we have this triangle that is here, We can also make use of it. Since this one is 90 degrees, we can find this also by using the sum of angles in a triangle. We can make use of what we just did here also, So for this one, I'm just going to be Okay, we're going to say C angle, not C, this is not going to be angle C, it's going to be this one that they say DCA plus angle, this one that they say, it's not D because it's going to be CDA plus angle A that we just found there. If we add those kind of terms, we're going to get verse 180. The reason is because sum of angles in a triangle, So we're looking for this one. So we're going to take this to the other side and also this to the other side. So DCA is going to be equal to 180 minus 68 minus 90. So DCA is going to be equals to 22 again degrees, So remember, our question is looking for the size of sine DCA. So they're looking for the size of sine DCA. Now we know the value of sine DCA, the angle is 22. So we can just punch this in our calculator. So if you punch this in our calculator, we're going to get 0.37 as your answer. So this is how we find this one. It was a 2 marks question, but I think it will make sense to you. Let's just take a look at the last question. So here they say we must calculate the length of AC, So there is a lot of ways that we can be able to find it. Remember, guys, let me just write down what we're given. We're given that we calculated this is the same as 0.4. And then we also know that this is equals to 22 degrees. And then we can find it using a trig ratio, actually, if we make use of this triangle that is there. So if our reference angle that we have, we also have another one. Okay, let's just make use of this one that is there. So this is going to be the opposite side, this one. And then this one, which is AC that we're looking for, is going to be the hypotenuse. So which trig ratio that is it talks about opposite and hypotenuse is going to be sine. So we can make use of sine here. So I'm going to just say sine of this angle, which is sine A, is equal to the opposite over hypotenuse. So sine of A is equal to 22, which is equal to the opposite is 4,04 divided by the hypotenuse is the AC that we are looking for. We're just going to cross multiply AC multiplied by sine 22, which is equals to 4,04. So going to divide both sides by sine 22 and then sine 22 on the other side. And then AC is going to be, this is going to cancel this. And then let me just punch this in a calculator. So this is going to give us 10,78 centimeter. So now we have reached the end of this question paper. Thank you so much for watching up until the end, and if you have found something useful on this video, you can subscribe and share it with your friends, recommend this channel to your friends, and drop a comment section which paper that you want me to do next. And then if you are very kind, there is a button here on your comment section to just donate some little bit money for me if you want to. But yeah, if you like to appreciate me with that, I would really appreciate it so much. So thank you so much for watching. Comment in the comment section which paper that you want me to do next. Thank you so much for watching.